Good afternoon, everyone. This is Robert Haynes with the National Weather Service in Burlington. Can everyone hear me okay? If you're unable to unmute your audio, let me know. Sometimes I need to send a pin for that. But otherwise, if you can hear me, just let me know in the question tab. Good afternoon and welcome to those joining in on our virtual training course. We'll get started in a couple minutes. I do see a few that still are not connected to audio. At intervals, I'll unmute participants and times for questions due to the large number. We'll save it for those question slides. But otherwise, if you are unable to hear the audio via the computer, you can set up through the phone option. There will be a set of instructions that'll tell you the number to call, the access pin, and then there's a third audio pin that you use to chime in. We will get started in just a couple minutes. Good afternoon to those joining the call so far. Just a quick reminder, if you don't have a microphone or a speaker on your computer, you can set a phone audio option. There is a phone number that you can call for that. It's unique to every person. Then there's an audio pin as well, and then a pin that accesses the presentation. So if you aren't able to chime in through a computer, you can try through the phone audio, and then we also have a tab for questions where you can ask them there in a chat box, and I'll be sure to check those from time to time. Since we are expecting a large number of people, I have most everyone muted at this point. When we get to question slides, we'll unmute all of the different participants that we have on board, so that way you can ask your questions. Just make sure that your mics are at least muted before I do that, so we don't have a lot of noise when that happens. We'll get started in just a few more minutes as we have people still signing in at this time. Welcome to those who have joined, and we look forward to getting started in just a little bit. All right, looks like our new number of attendees is starting to level off. So we'll go ahead and get started on the National Weather Service Burlington Skywarn spotter training for fall and early winter hazards. This will be a little bit more of a general course. There will be some information about storm spotting, but the primary focus is going to be fall and early winter hazards. Just one last reminder to those who've continued to join on the call. Most everyone, if you have a microphone or a speaker, GoToWebinar should automatically recognize that and set you to computer audio. But if you happen to not have a microphone and would like to ask a question, you can set to phone audio. There will be a unique number for you to call. There's an access code for our webinar, and then there's a separate access code for the audio. So it is a little bit of a three-step process, but there is a question tab as well. You can type in questions to me there. I'll make sure to reiterate those for everyone. There is a handout. You can also see I've saved a PDF format. Of course, those slides with animations will be a little bit messy, but on those, you can review it for later. Also, you'll notice I have on the top right here, I'll have each of the different slide numbers. That way, if you have any questions, we can easily go back to any slide that you reference in a question. With that, welcome everyone to the Skywarn Spotter training, and this is Robert Haynes, and we'll go ahead and get started. So what is Skywarn and what does it mean? That's going to be the first topic for this presentation. We'll go a little bit about what the Weather Service is. We'll do a brief overview of thunderstorm types and spotting. Then we'll get into our main focus of fall time hazards, which typically are strong winds and flash flooding. Then we'll start with our early winter hazards. Typically in this time of year, flash freezes, heavy wet snow, or snow squalls are some of the things we look for in our early winter period. We'll talk a little bit about how to best measure snow and ice as well. And then new to NPing is the ability to add snow squall reports. So we'll also focus on that. So what is Skywarn? We are a national network of volunteer weather spotters. Skywarn spotters originally had their roots in amateur radio. Amateur radio operators would relay information that they received, whether or not they were spotting themselves or from other amateur radio operators, and they would relay that to us so that we could get some ground truth that has since expanded and has grown further thanks to the advent of social media. Any Skywarn spotter reports any form of significant or severe weather. In the case of yesterday or today, we received a lot of precipitation reports. But any Skywarn spotter is trained by the National Weather Service. That's the key thing. We kind of collaborate and coordinate the Skywarn program here. Those of us who are weather spotters as well, and just kind of make sure you're up to date with various weather knowledge and provide avenues for virtual courses like this. So who can be a spotter? There is a wide range of people who can be spotters. Amateur radio operators were some of the first, emergency management officials, firefighters as well, and local law enforcement. But we also have spotters amongst the media, amongst researchers, college and university students, as well as the general public, people who do storm chasing, as well as those who take volunteer observations like co-op and CocoRa's. How to become a spotter? Many of you are here because of your interest in the program. There are no membership fees. This is something that's completely free and voluntary on your part. Basically, as much time as you'd like to commit to it is up to you. We only ask that you are trained by a forecaster from the National Weather Service through any of the following. That can be an in-person training session, which unfortunately we can't do in this current COVID-19 climate. But in the instance, to try and cover for that, we have the virtual courses like we're participating in now, and then there's also an online course on Comet MetEd. So if you do happen to get registered and then move to a different location, we encourage you to contact that region's local National Weather Service, and we can get in touch with them about your certification and that you've been with us and providing reports. So upon completion of this course, if you would like to become a spotter, we would ask for your physical location, whether that be a latitude or longitude if you're not comfortable with an address, as well as a contact number that you commonly use. It happens to be that if we notice a storm might be near where you're at, we might contact you if we notice that there's something and we're looking for a little bit of ground truth. You can let us know, of course, if that's not something that's preferred. Again, something completely voluntary, up to you. After the webinar, feel free to send me or the email that I have attached at the end expressing your interest. So why is it that we do need spotters? We have all the radar tech, the satellites, all these fancy weather model datas, but they are limited to some extent. As you can see here, we have a radar scan on the top left here. This is the lowest scan that we can see, and the radar beam in the Northeast Kingdom is already at 4,000 feet high. The issue is you have mountains like Mount Mansfield and Camel's Hump that results in blockage of the beam. So you can't really see anything unless you go higher and higher up the radials of our radar. So as a result, there is a certain area where we can't really see anything. The radar might see what's happening up above, but the spotters are going to be who sees what's happening on the ground. So in that way, a trained spotter is essential for us. They provide ground truth, helping us to report whether that's accurately happening, even if we cannot perfectly see what's occurring on radar. That helps us provide timely warnings, helps us provide more accurate warnings, and lets us know where impacts are occurring. So with that, we'll kind of transition to a broad view of what the National Weather Service is. We provide weather, water, and climate data, as well as forecasts and warnings that protect life and property and enhance the national economy. There are 122 different offices, 120 of those within the United States. We have Burlington, that's us. We cover this area of far northern New York, as well as most of Vermont. But you can get a sense that there are a large number of local offices that help us to kind of delegate the load of dealing with severe weather for our local areas. Our vision is to be a weather-ready nation, and Skywarn is a part of that to help us prepare and respond to these weather, water, and climate events. So here's a map just highlighting a lot of the different, as you go up the ladder, we are a line or a field office. We're kind of the first, we're the front lines for our local area. But as you expand, all of this area of the eastern US is covered by the eastern region. And then you have the southern states covered by the southern region. And then you have the national headquarters centered in Silver Spring. You have other centers like the river forecast centers located across various river basins highlighted in the shaded blue areas. And then we also have things like the Space Environment Center, which does space weather forecasts, and the Aviation Weather Center as well. And then let's see, any that I missed? Oh yeah, the INCEP centers. We have places like the Storm Prediction Center that do all the convective outlooks. There's the National Hurricane Center as well in Miami. And so we are just one small part of this branch of NOAA that works to try and provide all of these different informations, forecasts, and keep you safe. We're a branch of NOAA that focuses on these northernmost counties of New York and all of Vermont, except Bennington and Windham counties of Vermont. That's in Albany's area. But we operate 24/7 to provide these forecast and warning services. But even more than just forecast, we research the weather and climate in our local area. That way we can better serve you when we know a little bit more about our region's specific climates. We coordinate and volunteer observers across our region through co-ops and COCO-RAs and through Skywarn, and also collaborate with academia on research. Our area of responsibility covers a wide variety of geography. We have plenty of valleys, the St. Lawrence River Valley, the Champlain Valley, and of course the Connecticut River Valley. With each of these hills and valleys comes a lot of different complex weather events because we have such varied topography. So we have a wide variety of, this topography makes for a wide variety of challenges where you might have rain in the valleys, but you have to consider mountains, snow in the mountains. Places like the Northeast Kingdom can behave totally different from the Champlain Valley. Cold hollows can make places like Island Pond significantly colder than most of the area. So understanding these different regimes is what we are here to do in helping us provide more accurate forecasts. Before we get started on the bulk of our discussion today, are there any questions about Skywarn, about the National Weather Service in general, or anything else that comes to mind? I'm going to unmute everyone here, so make sure you're muted before speaking here. But we'll open the floor for questions. I see a question that someone is stuck in the PDF screen. I think I should be sharing the PowerPoint on monitor 2 here, so you should be able to view that if you are. The PDF is just something for you to reference after.
Yes, I have a question.
Questions. Sure.
I have a question. How much of this information is fed to the FAA for aviation? Any of it? Probably they're up in altitude, obviously, mostly, except ground, airports, etc.
There is an aviation weather center that covers more of that, and then the Center Weather Service Units, or CWSU, they provide much more in terms of aviation. The TAFs that we issue here at the National Weather Service primarily is for kind of situational awareness.
Okay.
So with that, I think mostly the Aviation Weather Center would be those that interact, and like the CWSUs would be those that interact more with the FAA.
Sure, thank you.
Mm-hmm. Any other questions out there?
Well, Robert, I noticed you had the Passumpsic Valley as a forecast area. Is that because of the propensity of the Passumpsic River to flood? So is that mostly because of its flooding ability?
I mainly brought that up because we kind of have to coordinate that with the with the forecast office that's in Port Gray, Maine. They cover all of New Hampshire. But yes, that is an area that's quite flood prone. The Connecticut River Valley is a little different from even like the Champlain and St. Lawrence Valley. I'd say it's a little bit narrower, and so that's why we kind of wanted to highlight some of that as well.
Okay, thank you.
You'll notice we don't really have a good name for the region of Lamoille, Washington, and Orange. We have a lot of names for a lot of these other ones, but we couldn't really think of a good one for that section of the world. Any other questions before we move on? All right, nothing heard. We'll go ahead and get started on the rest. So let's see. All right. So we'll go over a brief overview of thunderstorm science and forecasting. The three main things that a thunderstorm needs is moisture, atmospheric instability, which you might hear us refer to as CAPE, or forcing mechanism, which can be caused from a frontal boundary like a cold front. A variety of other factors can combine to make storms more or less organized. In general, the more organized a thunderstorm is, the greater the severe threat will be. As we go into October, the climatological period of our severe weather is coming to an end. The main reason for that is we're losing our daytime heating. At this point, aside from the abnormally warm days we had a few days ago, we've typically been hitting only into the 60s, which just isn't quite enough to produce large amounts of atmospheric instability. With that, you have less moisture as well. It's as you get cooler in temperatures, you also cannot hold as much water vapor in the atmosphere. And so with that, that reduces that thunderstorm ingredient as well. However, at this time of year, forcing mechanisms can still do a lot of the legwork. We do have severe events that do occur in October with strong fronts. Often you also have that unseasonably warm weather like we recently had, but we didn't have quite enough instability on that event last night to make for any stronger storms. But at this time of year, the severe threat is generally done for our forecast area, but it is still possible. The first kind of cell, the least organized, is a single cell. We often refer to these as popcorn thunderstorms. They typically are small, brief, they're rarely severe. They are driven by afternoon heating in an environment that's conditionally unstable. And so that allows them to grow, but then what ends up happening is that they typically don't move. And so what you end up having is you have a thunderstorm that gets choked by its own downdraft. So with that, These storms typically produce brief, heavy rain. They can produce clusters of lightning strikes, and in some instances, they can make for microbursts. That's the primary threat from a single cell thunderstorm. Any storm is capable of producing these. So that's the number one thing that happens. You'll kind of see this is a little bit more of an extreme example where trees are kind of flattened like a pancake. That's the indicator of a single cell thunderstorm's microburst. In the case of like a tornado, what makes that different is that you would have something that's rotating. And so that would have trees facing one way versus the other. So with a microburst, they're all facing one direction because air is simply coming straight down and flattening it out as it hits the ground. A multicell is a little bit more organized. They're very common in the summer months. They form from the merger of multiple single cell thunderstorms. With that, you get a little bit more organization. You can have features like the Gust Front, which you can see oftentimes these are areas of just a little bit lower reflectivities, and you'll often see them kind of expand in the opposite direction or perpendicular to thunderstorms. These type can be they're a little bit more likely to be severe. They can produce winds through things like these gust fronts. They can also produce hail. There's a low end chance of tornadoes, but the biggest threat for multi-cell type convection is definitely flooding. If they're slow moving, or if the rainfall is continuously moving over the same area, or training as we'll call it, that's when you have flooding from a multi-cell or pulse convection. A squall line is even more organized than a multi-cell cluster. I do see a quick question. We'll go ahead and answer that right now. Yes, a gust front is the same as an outflow boundary. They're very similar. So what ends up happening is rain-cooled air from these thunderstorms expand outward. You'll create these little outflow boundaries. They act a little bit like cold fronts, but they're much smaller in scale. They can play a big part in trying to forecast where new thunderstorms will develop, and also where they might end up dying out if a thunderstorm's already in these cool envelopes where they're kind of before where the gust front is, like it's already moved south. All this cool air cuts off some of the instability in the thunderstorm. Good question. So the squall line is a little bit more organized than a multi-cell cluster. What happens with these, you have an environment that has a little bit more shear. And what that does is that allows these storms to kind of form in a little bit of a line. And so what you have is you have these winds that are coming in on the backside of these squall lines. Sometimes they'll run a little bit ahead of it. Sometimes they'll be kind of right behind it. But these are very organized. And with that, you can have more straight line winds. And sometimes they can be particularly intense. Along these, you can also have short-lived areas of rotation ahead of these squall lines, and that can produce tornadoes that are typically a little bit more short-lived, but they can sneak up on you in these squall lines, or their more technical term, a quasi-linear convective system. So with a more organized system, you have much prettier clouds. They're a little bit more ominous though. When you see something like a shelf cloud on the left, this is a good example of a squall line that went through Colchester. This tells you that you're looking at very heavy rain and damaging winds are likely. As you get kind of behind this, you can kind of see the nice clear skies on the right side of the picture, and then on the left you can see it's a little bit foggier because of the very heavy rainfall. Sometimes what can also end up happening is you can get little roll clouds. The warm inflow into these thunderstorms as they're kind of propagating one direction will meet up with the gust front as they're moving out. So that can create these little turbulent eddies that make these roll clouds. Here's a good example of a shelf cloud that we recently had here in Burlington from this year. Excellent structure, just you can see like these little series of clouds running ahead of the main line of thunderstorms. And you can see a little bit of different coloration as well in the clouds. Sometimes that can indicate that there might be a little bit of hail involved as well, because the hail is going to scatter light a little bit differently than a water droplet. So with these, you'll see the straight line winds with rain blowing sideways, pushing down the trees, generally making for about 10 to 15 minutes of generally unpleasant weather. And then once the squall line has moved past, you are pretty well done. I do see a question from Diana. What distinguishes a derecho from a squall line? That's an excellent question. Derechos are a little bit more extreme than a cold front, but they are a special type of system. They kind of form typically during the summer months, actually, when cold fronts are typically weakest, but it's all generated by convection. And what happens is these thunderstorms kind of generate their own rear inflow into these thunderstorms. They'll bow out and form like a bowing segment. So as opposed to being a straight line, like this one's relatively straight, but they might bow out more like at an extreme angle where it's like they kind of come back in and then bend back on the other side. I don't have a good picture of a derecho here on these, so unfortunately I can't be able to show you a good example of one, but those are typical in the summer months, generally caused by extreme heating during the summer months in the Midwest. We can get them up here. They're a little bit more uncommon. The most recent good example that we had, I think, was the Adirondack derecho. I'm trying to remember, has it been 25 years now? Was it what, 95 that occurred? Sometimes they can occur in the middle of the night because that was early in the morning that one took place. But derechos are mesoscale systems. They start from a cluster of thunderstorms that evolve over time into these bowing segments. So they're a little bit detached from areas of large scale low pressures or from cold fronts. And the supercell is a highly organized thunderstorm. These feed on very strong updrafts that are tilted and rotating. So kind of consider, you might have a south wind at the surface, but as you go higher and higher in the atmosphere, your winds might become more southwest and then westerly. And so what that does is as the air parcel moves up into the air, it'll begin curving and rotating. What this does is a couple of things. The downdrafts can come up on the other side and help form an area of rotation, which can become tornadoes. Additionally, you can get stronger hail because your hail, a lot of times you want to have it updrafts and cycling between the freezing line, coming up and down. Having that rotation helps hail to cycle through several times before it falls to the surface, allowing for larger 2 to 4 inch diameter hail. These will also last a little bit longer than a single cell thunderstorm, and they aren't as fast moving always as a squall line, so they can persist longer in a more favorable environment. So like I mentioned with supercells, hail is a little bit more likely. Hail starts by raindrops coming in a warm updraft, and they start to freeze once they get above the freezing line. And so what happens is as they start to get into the downdraft, they'll start to fall, they'll melt a little bit, but then they'll get caught back up again by the updraft. What ends up happening by this repeated cycling of melting and refreezing is you'll get these neat little layers. So if you were to cut it open, this is kind of what it would look like, where you'll see different layers of water kind of expanding. So once the hail is too heavy, once its weight is too much for these updrafts to relift back up in the atmosphere, they'll fall within the downdrafts of the thunderstorms. So what will make hail more likely is when these updrafts are very strong, allowing them to loft high up into the atmosphere, or when this freezing layer is a little bit lower in the atmosphere, a little bit less room for it to melt before it reaches the surface. And again, to emphasize the fact that we can get severe weather even outside of our severe season and without all of the ingredients that we mentioned. Last year, we had this good example of a supercell that occurred over Messina, New York, almost 1 year ago. It was only about 60 degrees, but a supercell managed to form. And what ended up happening is we had nearly 2-inch hail reported in Messina on that day. That was a particularly impressive one. And on a day you might not expect it. So supercells can make things a little bit more challenging for us because they can overcome lack in heating that might be at this time of year. Let's talk briefly about tornadoes. We'll only go between like the weakest and the most violent tornadoes. In general, a tornado is a violently rotating column of air that's in contact with the ground. When it's not in contact with the ground, that's when you have a funnel cloud. They're very rare up at in this region of the world. We typically get one every 2 years in this area of the world of northern New York and Vermont. They're a little bit more common in Bennington and Windham counties. From there, you have just enough extra heating and less mountain coverage that helps tornadoes to develop a little bit more favorably down in that area. Tornadoes do have lookalikes. There's scud and convective debris clouds, and they look like they might be funnel clouds, but they actually aren't. The main way that you can tell these features apart is it attached to the cloud. Sometimes as you're watching it move, you'll see it move and then you're like, oh wait, it's not quite attached to the cloud. Another good way to tell scud or convective debris apart is whether or not it's ascending into the cloud or if it's descending. If you'll note these clouds, if you see them coming up, you're not really looking at a funnel cloud just yet. You want to see a nice organized wall cloud, and you want to see something kind of trying to make contact with the ground. That'll be one way you can kind of differentiate between scud or convective debris. If you are asking us to evaluate, these questions are hard to answer without video or the time of occurrence. We need kind of some of that information to help us match it up with what we can see on radar. That helps us to verify whether or not that funnel cloud occurred with rotation that we can see on radar. And when we have video, that helps us see whether or not it's rotating or ascending or descending from the clouds. So it can be sometimes hard to tell completely if something is that, or it can even just be a rain shaft. Where at the backside you have clearing that's just with this little nice area of rain. Sometimes the turbulent flow can make it look like you have an area of rotation when it's just part of the rain shaft. Weak tornadoes, these are 80% of all tornadoes, but generally they account for less than 5% of tornado deaths. They typically are short-lived, just 1 to 15 minutes, and their path lengths are typically up to 3 miles. Wind speeds with EF0s or EF1s are 65 to 109 miles per hour, so they can definitely uproot trees, do damage to sheds, farmhouses, and buildings, and they can cause injuries. Most North Country tornadoes are going to be in this EF0 or EF1 category. On the extreme end are the violent tornadoes, the EF4s and 5s. They're very rare. Only 1% of all tornadoes are going to be EF4s and 5s. And even considering this, that supercell, like even in a supercell, only a fifth of all supercells are going to have a tornado associated with them in the first place. So EF4s and 5s are quite rare. They need just the right environment to develop, but they're very violent. So they cause 70% of all tornado deaths, even though they only account for 1% of all tornadoes. Due to the more favorable environment, they also last a little bit longer, 1 hour or higher. And sometimes they can extend for over 50 miles if they're long tracks. Wind speeds with an EF4 or 5 up to 168 to 234 miles per hour. So just between the extensive path, the strong violent winds, these are very dangerous to life and property. But fortunately, we have never seen anything higher than an EF2 in Vermont. So hopefully we won't see that change anytime soon. When you report severe weather, we've touched on this a little bit, but it's important for us to know when you see these kind of events to let us know where you are located, what severe weather you had, whether it was damaging winds, whether it was hail. You can use common household objects to help us imagine the size of the hail. What time did it occur and how long did it last? And sometimes we can't keep track of who everyone is. So let us know who you are and where you're at so that we can properly apply that to what we see on radar. Additionally, it's also nice when we get heavy rainfall reports. We always appreciate those because they can tell us a little bit about what might take place with regards to flooding. So before we get into fall and early winter hazards, Are there any questions about severe weather, about reporting severe weather, or anything else that comes to mind? I'm getting ready to unmute everyone, so get your questions ready. All right, you should now be set.
Hey, Robert, I frequently use the Radar Scope app, and I'm out in Lyndonville. And I noticed you had a slide earlier talking about radar tilt elevation angles. And when I'm looking at a severe system coming through, and I look at the velocity mode, and I'm looking at a couplet, that's probably just upper level rotation, right? Just because of the beam angle.
Yeah, that is one of the things that's particularly difficult about Eastern Vermont, is that when we are looking at places like Lyndonville, the radar is intercepting up to 4,000 feet above the ground level. And so as a result, we can't really see a whole lot of the rotation that's coming down. We do have a chart that we easily can refer to. It kind of helps us measure how much the rotational speed is. There have been studies done that kind of recommend when you should warn for different rotational speeds, and we'll use that from time to time for far sections of Eastern Vermont. And we also, again, rely on spotters to help kind of make up for the gap of 4,000 feet that we can't really see below.
Okay, thank you.
Mm-hmm. Any other questions out there?
Yeah, this is Chuck Gawler. I'm in Williston. I just had a question regarding reporting and location. What's your preferred mode of location reporting in terms of latitude, longitude, address, the various other kinds of systems?
Great question. So the best way is to provide what road you're on. That's typically the way we'll find you. Any landmarks, like any well-known building or memorial, those can be ways that we can find your spot, even if you're not specifically like at your home address or something like that. So if you're out on the road, let us know which road you're on. I think we now have mile markers along parts of our interstate, so that can also help on that front.
Okay, thanks.
I see a question here. Is there any coordination with Canadian spotters on the other side of the border and vice versa? Not too terribly much. Sometimes we'll get contacted from the Environment Canada. They have an office up in Quebec City that organizes the weather out in that region of the world. Sometimes they'll contact us when there's a supercell with a confirmed tornado. But it's not too often that we do collaborate with them. Part of it is a language barrier. I think a lot of the forecasters there primarily speak French, and we don't have too many French speakers in our office.
Robert, this is Rick in Lyndonville again. Since you mentioned Canada and Quebec, does the weather office, does the WFO in Burlington ever use other radars besides KCXX? Do you use the Blainville radar in Canada, or the Gray Main radar in Maine to look at what's going on in Eastern, especially the Northeast Kingdom? The Canadian radar seems to have a little better view of the Northeast Kingdom from what I've seen.
Yeah, occasionally we'll pull those up, and areas like Messina, there's a radar near Ottawa as well that we can use that gets us just a little bit lower of an angle. We also use KTYX. Occasionally Albany's radar in ENX is also useful for seeing what's happening down in Rutland County and Windsor County. Gray it's just about an equal distance from like us to say like Brattleboro versus the Port Gray radar in Brattleboro as well. They're almost the same distance. So it's a little bit more situational using GYX, but we will pull it up from time to time.
Okay, thank you.
Mm-hmm. Are there any other questions out there? All right, we'll go ahead and get started then. I'll go ahead and mute everyone at this time. All right, so as always, you can continue to ask questions in the question box. All right, let's get on to fall and winter hazards. So as we transition into fall and early winter, the big thing we think about, we go from worrying less about flash floods and more about just flooding in general, but then we also transition just to thinking more about wind. During the summer months, we don't see as much wind, but we issue a lot of wind headlines and high wind warnings at this time of the year. We've been doing a new research. It's still a little bit of a work in progress, but just to kind of show you that as we get into October, November, December, and January, that's when you start seeing us issue a lot of those winter weather advisories for strong winds. So we'll go over a little bit about why that's the case, why we end up seeing more winds in fall and winter. And then we'll go as to why, even though we see a little bit less of a flooding potential, there's like a little bit of a secondary max in November, and we'll discuss why that's the case. So just to briefly touch on Lake Champlain, at this time of year, it's very favorable for fast winds out on the lake, and that's all due to how sea surface temperatures are very different from how the air works. Takes a lot more effort a lot more energy to change the temperature of water than it is to change the temperature of air. So what happens in fall, during the summer, Lake Champlain has had all this time to heat up, and all of the air is already warm as well. As we get into fall, it now takes more effort to warm the lake. So now the lake is quite warm. It's still about 64 degrees or so, but we can get these cold snaps in September and October that take air temperatures down into the 30s. What that does is that makes for very unstable conditions out on the lake. That makes it much more favorable for winds that are aloft to mix down towards the lake surface, as well as channel down the valleys. With the combination of stronger systems at this time of year, it makes fall and early winter some of the windiest times on Lake Champlain. And we have started seeing that occur. We are starting to see periods where the lake will gust up to 30 to 40 miles per hour and starting to see wave heights come up a little bit. So it's that time of year where we start seeing much more wind out on the lakes. And then this is just a graphic to also highlight, this is the frequency that Colchester Reef gusts above 25 knots. And you can see all the different years that we have here. And you can see that it maximizes as we go up into November, December, and this is January. So we're getting to the point where the lake is windy. Once it ices over, you don't really get as much wind on the lake because at this point your lake is frozen. So once we get into the brunt of winter, we won't be seeing as much wind out on the lake. So going to why the wind threat is greater during the cold season. During the summer months, we are roughly the same temperature as the southeast, give or take about 10 degrees. Less contrast in solar radiation in the summer months, and what that makes is differences in temperature are not as strong. With that, we don't have upper level winds that are as strong, that don't really mix down to the surface as much. A combination of these factors make areas of low pressure generally weaker outside of any convective or tropical lows, like from a derecho or a tropical cyclone. So in general, winds are lighter in the summer months. As we flip over to winter though, our temperature contrast between us and areas of the southern US are a little bit more extreme, on the ballpark of 30 to 50 degree difference. What that does is the atmosphere wants to try and restore a little bit of balance. And so what's going to happen is you'll cause what we often call a thermal wind to develop. What that does with the stronger temperature gradient, you're going to get more wind flow out of the south and also from the north when we get these strong systems that develop. Conditions are generally more favorable for areas of low pressure up in Canada to strengthen, to deepen, and become stronger. And so with those combination of factors, we are more likely to see tight pressure gradients between very strong areas of low pressure and very strong areas of high pressure. This can be seen in things like the Halloween windstorm, which we had last year. This was a significant rain and wind event that made for a miserable Halloween night with both strong winds, heavy rain, and flooding. We had a 986 millibar low pressure coupled with a 1030 millibar high centered over Tennessee. And so when you have these strong pressure gradients between an area of strong high pressure and strong low pressure, you'll create very high wind speeds. We had a widespread anywhere from 30 to 50s. Any of the downslope areas had 60 mile per hour wind gusts. Mount Mansfield gusted to 111 miles per hour. This was a significant windstorm in our area, putting nearly 120,000 people without power during this event. Just a classic case of how a transition in season brings about these gustier windstorms into our area that aren't always welcome. 3 years ago, we had another strong windstorm that did something a little bit similar. Again, an extreme pressure gradient here caused by a broad area of high pressure at 1000 at 1024 millibars and an area of strong low pressure at 975 millibars. Very strong for this early in the season. As a result, strong downslope winds came off the Green Mountains. We had 60 to 80 mile per hour wind gusts in Rutland. Overall, there was widespread tree damage. 60,000 plus people lost power, bringing us to an estimated $4.8 million in damages. This was a significant windstorm. Many utility companies got involved into the recovery effort, especially I think in like New Hampshire and Maine were particularly hit hard by this very potent area of low pressure that developed 3 years ago. So that's a little bit how our wind threat evolves. We see much more active areas of low pressure. With that, we get stronger pressure gradients that focus the wind, kind of like a little bottleneck. It forces the winds through. But we also see a development of different kind of flood potential. Whereas in the summer months, we have more of a flash flood potential related to thunderstorms. With winter, we see a little bit of a change. During the summer months, the jet stream is usually weak and fragmented. We'll call these jet streaks. Cold fronts are not as strong because we don't have as strong of a temperature contrast between us and the south, but there is a little bit more heat and moisture content, which makes flash floods a little bit more of a threat. As we gear towards winter, though, the jet stream is now strong. We have stronger areas of low pressure, and we can get little moisture taps between us and the Gulf of Mexico, sometimes even a little bit more efficiently than the summer months, just because of how strong these systems are. Just like the one yesterday had a nice tap between us and the Gulf of Mexico. Fortunately, didn't have the wind component as much, but at this time of year, the jet stream becomes more established. We can mix in a little bit more tropical moisture. If there is a tropical storm or a hurricane that's recurving upland as well, they can interact with these systems and they can, depending on the setup, make for either a flash flood or an organized flood potential out on those rivers. We've had a fairly dry summer this year, so fortunately we're not looking as much of a flood threat for any of these organized systems. They'd probably be a little bit more welcome for us given our recent dryness. But in wet years or wet summers, these can be unwelcome because they can cause river flooding or flash flooding in our areas. One good example of this is the Great Vermont Flood of 1927, which took place November 3rd or 4th. This developed from an area of low pressure that started offshore. There was actually a tropical cyclone a little bit further southeast. The moisture from the tropical cyclone was integrated into this area of low pressure. It produced impressive amounts of rain over parts of Vermont. We don't have as wide of a network from back then as we do today, but areas reported 8 to even 9 inches of precipitation, and it caused pretty much, I think this is Vermont's greatest disaster that's ever occurred from an environment perspective. And the Halloween storm again, we mentioned the wind threat of this, but the Halloween storm also caused quite a bit of flooding. Just a reminder that a tropical cyclone is not necessarily required to make these events impactful. There was no tropical cyclone that was involved in this one, all just pure dynamical and synoptic forcing. Strong area of upper divergence. You can kind of see how the cloud pattern kind of fans out here. That indicates that you have good upper divergence, which what happens is as you get more and more of this moisture, it has favorable upper conditions to produce several rounds of precipitation. We had a small, narrow area of 2 to 5, locally even 5 inches of precipitation, I think in some areas were reported, and that brought some record flooding. Have a quick little animation here to even show some of that, or you'll see like one round of precipitation that comes in the afternoon, another that came through later in the evening, and then even later, we had stuff at 10 and even midnight. It just kept coming and coming and coming. As a result, we had quite a bit of flooding. I think it took North Troy to a record flood stage from this event alone. So this time of year, we can get strong, organized areas of low pressure that make for a flood threat. With flooding, always make sure, turn around, don't drown, and make sure that you're safe if you're going to be reporting flooding at a high spot where you're not going to be caught in any of those flood waters. You can often have severe or active weather or storms during these events. Use your best judgment as far as whether or not you need to be getting to higher ground or if you need to be hunkering down for a potential tornado. So just on the subject of kind of the transition in the seasons, what that means for a general weather pattern, what that means for strong winds, what that means for flooding in the fall, any of those questions that you have or anything else that comes to mind, we'll go ahead and unmute here. I do see a question here. Is there a recommended height for anemometers or personal weather stations for the most accurate surface wind observations? I think anemometers are, I don't remember what height those are, but I do know winds, the standardized height is at 10 meters above the ground. That way you can kind of get yourself above the friction of the land. There are some towers that measure at 20 meters, and I know there are some wind sensors kind of off the roads. Those are going to be a little bit different, but generally we try and aim to make sure that they're not against any building or mountains, so we can get measurements from winds from all directions. So that's a good question. Any other questions about winds and flooding in fall? Nothing heard. We'll go ahead and start our early winter hazards. So one of the big things about this early portion of winter is that many of our regional temperatures, normal temperature ranges are anywhere just above freezing to right around freezing, and low temperatures are well below freezing. So with that, our temperatures still will rise above freezing during these early stages of winter, which sets the stage for two different types of hazards. That can either be icy precipitation or it can be a flash freeze. Those will be the most common things that we look for during the early winter months. So the question is, what precipitation type will it be? We're getting to that point of year where, or that time of year where it's no longer assumed to be rain. I know at our mountain summits, we're starting to think it might be starting to get cool enough. There might be some snow on the summits in the not too distant future. So it's at that time of year where we start thinking, what precipitation type will it be? So whenever we have a dendrite form in the upper area of the atmosphere, as soon as it reaches an area that is near to above freezing, it'll begin to melt. And assuming that there is enough distance between when that snowflake or dendrite begins to melt and reach the surface, that it falls as rain. On the opposite extreme, even if the temperature is just above freezing, at some point as you go upwards in the atmosphere, it takes a little bit more to melt than just being above freezing. So as long as your atmospheric profile as we go up and up in the air is below freezing, it should fall as a snowflake. Things get a little bit more difficult when the temperature profile as you go up is a little bit more complex. Say you have a stronger warm layer where you have temperatures that are below freezing for this dendrite, and then it becomes above freezing. but then when you get just right to the surface, it gets below freezing. What ends up happening is the dendrite melts, becomes rain, and then when it reaches the surface, it freezes on contact with that surface because it's below freezing. That's the most unpleasant scenario and the one we hopefully see very little of this winter. The other scenario you can run into is for ice pellets or sleet. You might not have as strong of a warm layer, and you might have a greater distance between the warm layer and the surface, such that as the rain falls, it refreezes into sleet before it reaches the surface. It doesn't really adhere as much to roads or power lines, so these are a little preferred over freezing rain, but not much more. So the question is, where's the low tracking? The low track is significant this time of year because we're not always consistently below freezing. So where the low tracks is going to be a big indicator of what type of precipitation we'll receive. I see a question here on the profile for Grapple. Grapple is a little bit different. Grapple is kind of like snow, but not quite. There is a favorable temperature profile for dendrites to form, and that's about at -10 degrees Celsius. I think that's, trying to remember what that is in Fahrenheit. I can't remember off the top of my head. I'm not going to do the math real quick here. So at that, you have a favorable conditions for dendrite formation. Grapple tends to happen when you don't have that. We have this kind of profile here that kind of shows snow, where you're spending a good amount of time and snow can become heavy or wet or produce really large flakes when it has this period where it's just above freezing. In the case of Grapple, you might have a profile where, so I think the moisture is also a significant part of this. Your profile is going to be, instead of kind of backing up to this warm air, it just kind of keeps getting colder and colder and colder. But you might not have a whole lot of moisture here. And so you don't really get these dendrites that have the nice like hexagonal patterns of a snowflake. But it's going to be something more like you're going to see these little ice pellets. We call it soft hail. That's I think the literal translation of what Grapple is. So what ends up happening, I think, is the way it tumbles and falls as it heads down towards the surface kind of gives it that weird little triangular pellet type shape. Grapple's a little bit different. Oftentimes we get those at the extreme, at the book ends of the season. Typically happens early in the winter season and then very late in the winter season. They're a little bit more convective. So steeper lapse rates or lake effect showers might be a little bit more geared to seeing Grapple. Also a good question here in the forecast discussion, seeing mentions of things like the benchmark. What exactly does that mean? How does that relate to the system developing with regards to winter weather? Lat long is usually given for this, but I can't remember what that is. Could you give a bit more information about that? So when we talk about the benchmark, we look usually at 40 degrees north latitude and 70 west longitude. And so what that means is going to be a little bit different for each location. So if we were in Boston, we might like seeing a storm system that tracks right over 40 north, 70 west. But here in Burlington, we might actually want it to be west of that point. So when we say we're seeing a low track just west of the benchmark, we're seeing a low pressure track that's usually favorable for us to see snow. If it's a little east of the benchmark, the moisture might be too far south and east of our area for us to see any appreciable precipitation. So 40 north, 70 west, that's the general point. And typically we'll go ahead and skip ahead a little bit, kind of defined by these arrows. I think 40 north, 70 west would be somewhere about here in this map. So well east of Long Island and just south of Cape Cod. So when we see a low that tracks just in this area, we'll see cold air well entrenched in our area, but most of the warm air is going to kind of be siphoned east. Going back up here, this is something that's often the Alberta Clipper, something that descends from the Alberta province in Canada, quickly makes its way eastwards across the US and can kind of skim our area. The question with these always is if they track too far north, what ends up happening is warm air can get into our area. So this is when we see more chances for mixed precipitation or rain as opposed to snow, is when the low is tracking too far to our north. Let's say the low tracks a little bit closer, where it's even right overhead or just south of our area. It'll kind of depend on both how shallow cold air is near the surface and how strong warm advection is, how strongly air is moving up from the south into our area. If that's the case, we'll see a quicker transition away from snow and into something like freezing rain or rain. However, if we're looking at deeper area of cold air, you have several thousand feet of cool air that's below freezing, or if this warm air coming from the south, if that stream is not particularly strong, we might see a slower transition away from snow, and we might see a little bit of sleet or maybe freezing rain. It just kind of depends on the scenario. How strong that warm advection is a key consideration when these lows track directly overhead. And then kind of we pointed to this one, anything that forms just to the west of the 4070 benchmark is our sweet spot up here. Boston area might prefer a little bit further south. This would be more of a rain profile in Boston's case if it were to track directly over them. So in general, when a low track is to our south, that's going to be the most favorable case for snow. Too far south though, and we miss out on any of the precipitation. And then there's always, once the low pressure system heads east of our area, that's when we start thinking about upslope snow events. What'll end up happening is moisture will wrap around the counterclockwise rotation of the area of low pressure, and it'll reach these little mountain areas, whether the greens or the northwest facing slopes of the Adirondacks or the White Mountains of New Hampshire. What ends up happening is this relatively moist air is aided by the topography of our region to produce localized snow events. These events can range from a trace to even several feet in the mountains. It just depends on how persistent this is. Is the low track moving slow? Is it kind of moving back into the St. Lawrence, or is it quickly moving off to the east? The longer it stays in place, that means the longer we have to build up more snow on the slopes for those skiers. Most commonly, these events will take place in November into December. We have two different scenarios from here that can play out. Let's see if we have a question here. Yeah, we'll save this question for the end. We'll come back to it. So once a low pressure system is east of the area, considering two different scenarios, whether or not our flow is what we call blocked flow or semi-blocked flow. In the case of blocked flow, that means we have an atmosphere that's very stable, relatively moist, so that whenever any wind comes up to the mountains, it's unable to ride over the mountain slopes. And so it ends up becoming trapped in the foothills or in the immediate valleys. When it's semi-blocked, you'll have a case where the atmosphere is a little bit less unstable, or I mean less stable rather. So what ends up happening with these, while your winds might be slowed down by ascending up the mountains, it's just enough that it can get over. As a result, you don't really get snow that's packed into the valleys. In blocked snow events, like this case in just at the start of 2010 in January, in the case of a blocked event, your highest snow totals are going to be focused in the immediate valleys where you're experiencing blocked flow. But if it's semi-blocked or unblocked, you'll see that it'll be focused more along the mountain peaks and maybe even just downwind of it, where you'll see less, like I think in this instance, Burlington and the Burlington area only got like about a ½ to 1.5 inches. So these are some of the different scenarios that can play out once a low pressure system moves east. How much moisture is still available, whether or not we're unstable or stable in the atmosphere. All these things are considerations that can give us a little bit of a bonus at the end of these low pressure systems. Andrew from Stowe, how has the experimental BTV fruit formula been performing? We do, so I mean, like the fruit formula is based on both like the static stability and the wind speed of the atmosphere. It's been around for quite a while, but I think it was only recently until we had better high-res models that we really began tracking these. The fruit formula is very useful. We find that it's generally very accurate in helping us to estimate whether or not snow will happen more in the immediate valleys and foothills versus whether or not it happens on the mountain slopes. It's a very useful system. We always have to make sure that we keep track of the winds. It's the way you just want it is the winds to be perpendicular to the mountain slope. So like if you're facing the northwest slope of these mountains, you'll want the winds directly coming up against it to get the most snow on those foothills. Conversely, if you wanted snow on the eastern sides of the mountains, you would prefer more of an easterly wind. Once you get on the other side of the mountains, you can get some terrain slope or downsloping where that can kind of cut into your precipitation totals. What are some of the favorable conditions for formation of a secondary coastal low pressure system? That's a great question. What ends up happening with these secondary lows is you'll have a, we'll try and, sometimes it's often these kind of scenarios where a low pressure is going to track over the Great Lakes region. And when these low pressure systems mature or occlude, they kind of linger in the same spot. They will occlude a frontal boundary that often likes to set up right along the mid-Atlantic coast. So if there's any upper level system, they can take advantage of this favorable area of convergence provided by the parent low system, and they can kind of go off into these kind of, we'll call them double barrel lows sometimes. And so with these, you'll want, with a double barrel low pressure system, that's typically when these upper troughs are a little bit more focused over the Midwest as opposed to being directly over our area. Generally, these secondary coastal lows aren't as favorable for widespread snow. What ends up happening with these, the parent low off in the Great Lakes will also push in a lot of dry air that's kind of wrapping around the circulation. What that can kind of do, that can remove some of the cloud moisture where dendrites like to form, and that's when you start getting some more sleet, graupel, things of that nature. Great question. This is also a good time of year for lake effect snow. We're seeing some lake effect showers ongoing today. It's not quite cold enough to produce a lot of snow at this point, but at this point of year, we've already mentioned how at this point, the lake temperatures are a little bit slower to cool than the air. So when we get these strong Arctic intrusions, what ends up happening is you create very unstable air. What you want with lake effect is you want winds coming along the long fetches of these lakes. So west or to just south of west wind is perfect for lake effect snow off of Lake Erie or Lake Ontario. If they're persistent, you can get these impressive snowfall rates. National Weather Service Buffalo in South Cheektowaga, they had 65 inches in less than 48 hours just from this strong persistent lake effect band. Very localized regions of high instability caused by the strong temperature difference between conditions near the surface versus what's happening up above those lake temperature of those lake surfaces. When you have those extreme temperature differences, you get these convective squalls of snow that impact just a very narrow area. You can see just how much of a gradient is between Buffalo proper and this town, where 65 inches versus I think only like 2 to 3 inches fell in like Buffalo proper from this event. This one was a particularly early season event that was fairly catastrophic. Snow squalls are another factor of early winter hazards. These will occur as a strong cold front comes across. As we've mentioned, the lakes are still relatively warm and they're unfrozen, so they're a good source of moisture for these cold fronts as they move eastward. These strong fronts will focus and allow for strong strong pockets of showers to develop. We like to call snow squalls as like a blizzard bundled into 30 minutes, where a blizzard is really long lasting. You'll only have a brief period of very strong gusty winds that reduce visibilities, and they occur rapidly. It's not like there's a slow, steady buildup. They kind of happen and then it's over. So with that, these can be particularly impactful if you're not expecting them. And so in 2018, we started warning and really tracking some of these, and we're still doing more work and research on these. Generally, the favorable setup is for a low track to the north, where our temperatures are cool, but they're warm enough so that there's just enough instability to produce these strong convective snow showers along these cold fronts. So let's see. A lot of the danger that also comes with snow squalls and these kind of fronts that kind of sag across our area is that we can get what's known as a flash freeze. Temperatures will be just above freezing in front of a front, and you might have this narrow band of precipitation that forms right along the cold front. Right behind it, you might have a sharp drop down into the teens and the 20s. What ends up happening is you have melted precipitation that's in liquid form on roadways and on surfaces that's above freezing. But then as soon as you drop into the teens to the 20s, that rapid cooling can result in all of that liquid that's still on the roads or ponded to quickly turn into ice. This can happen with rain or even snow squalls. Snow squalls often happen more towards like the just right at the freezing point. And so oftentimes the snow squalls can end up melting on roadways as they reach the surface and then become these icy skate rinks on the roads as temperatures rapidly fall behind any of those snow squalls. The flash freeze is a 30 to 1 hour hazard that can come quickly and unexpectedly. So we always try and make sure when we notice these kind of things to give the public sufficient lead time to prepare and avoid these kind of scenarios when they unfold. So flash freeze, generally that's defined as something where your temperatures are just above freezing, falling to temperatures that are well below freezing, sometimes in the span of even just an hour or 2 hours even. And of course, we can't go without mentioning safety. One of the key things as we go into fall and early winter, consider winterizing your vehicles and being prepared for the worst in case you get trapped in any winter weather. Making sure that if there is significant weather impacts expected on the road, to have your gas tank filled, to be equipped with a shovel or chains if needed, to have windshield scrapers and fluids that are set to last below freezing temperatures, have your booster cables prepared, your flashlight, cell phone, and flares. Make sure your cell phone's all charged. Have snacks just in case you're stuck for a bit, as well as water. I happened to live in Atlanta in 2014 when we were stuck for many hours in traffic. That was not a fun experience. I was trapped in a car for 10 hours and I had no food. Make sure you have a snack prepared in case you get trapped, because I was very hungry. Empty coffee cans, candles, or matches, ways that you can kind of build heat. Have a first aid kit or an electric, or like one of those little blankets. I can't remember exactly what they're called. Those are something that's useful. We'll answer this question real quick. When it comes to these various winter weather hazards, what sort of reports would you like from spotters? What sort of events should trigger us to give you a call? And are there other ways for us to make reports? Good question. And I actually did forget to include a slide on some of the things we like to see reported as regards to snow. We like to hear amounts. Amounts are always useful, but sometimes the rate of snow is useful. In March of this year, we had, or no, it was not quite March, it was February. We had an event where 3-hour snowfall rates were being achieved. And that wasn't entirely, we didn't entirely expect 3-hour snowfall rates on one of those events. So hearing the stream of calls of people reporting 4 to 6 inches of snow in a matter of a couple hours was really important for us. It told us we need to be ramping up what we're doing and ramping up our messaging. So heavy snowfall rates are something that's good. Anytime you have over 3 inches of snow is really important for us as well. With respect to snow squalls, we'd like to know if there were also gusty winds, because that's one of the criteria for a snow squall. It's not just really heavy snow, but it's also the combination of strong winds and really low visibilities. So if you're happening to note heavy snow, let us know also if you're seeing really strong winds or if it's just coming kind of all straight down with no winds. We also have a CocoRoS reporter, Rick Stevens here. So do you already get the CocoRoS reports for snowfall and rates, or should I also contact BTV? Yes, we do get all of the CocoRoS data that you report. We have to be paying a little bit of attention. We have to have the program open to view those. Usually if we're good on situational awareness, we will have those kind of things open. But if you are seeing a snowfall rate that's particularly impressive, sometimes it doesn't hurt to give us a call and let us know what you're observing so that we can see it before we note it in our programs that we have here. Other things to report, we'll go over ice and snow measurement in a few slides down. So let us know any of the ice measurements that you also have. Ice jams are also something that we like to know about. We keep track of all of the ice jams that people report to us over the course of the winter. That's an important consideration as we head into late winter and into early spring. Creates a different flood threat that we don't really see at any other time of the year. That'd be also something that's helpful to report as well. If you are stuck in your vehicle for the winter, always check the latest reports and winterize your vehicles before going out. Carry those winter storm survival kits. We've already gone over a little bit of those details, just to make sure that you're prepared so that you can stay warm out of the cold and that you're visible to rescuers if that's needed. Generally, just exercise, moving your arms and legs can help keep your circulation in the cold. And at home, if you do lose power, having an alternate heat source is important and that you can properly ventilate. But if you have no heat, make sure to close off unneeded rooms, stuff towels and cracks to prevent drafts, cover the windows at night, and wear layers of loose-fitting, lightweight clothing. You don't want that sweat because that sweat will evaporate and then cool you off. So make sure you're wearing loose-fitting clothes. If caught outside though, find shelter to stay dry. Cover exposed skin if you're out in the cold. But if there's no shelter, you can build a lean-to or something just to break the wind and keep you out of the snow. You can build fires for heat. You can set up rocks that absorb heat better than a lot of other surfaces. Melt snow if you're going to have to drink water from snow. Otherwise, eating snow will lower your body temperature and put you at greater risk for hypothermia. Wind chill is something that we also consider. As we note, we are looking at stronger winds during the cold season. What that does is your body is naturally radiating heat, but on a windy day, that's going to be carried away in the wind. That makes it a little bit more efficient for your body to cool off. So in a windy day, it's important to bundle up and cover exposed skin so that way you can keep your body heat. We are planning on doing a future webinar on avalanches. So we'll be talking a little bit about avalanche science in the not too distant future. But avalanches can be deadly. They're often triggered by people. It's important to know snowpack conditions. That's typically something we talk with emergency managers, rescuers, those people who are first responders to those who might be trapped. We have mountain point forecasts that you can find on our recreation page, and in the not too distant future, we'll have a little bit more information about avalanches. We're an experimental office starting this winter, so look forward to more of that coming soon. And of course, with shoveling snow, make sure to stay hydrated and take frequent breaks. If the snow is wet and heavy, it can put quite the strain on you and your back. So if that's the case, know your limits. So let's get into measuring snow and the guidelines for measuring snow. The official method is to measure the total snow depth on your boards every 6 hours. It's best to have a white board that doesn't really absorb a whole lot of heat. So any white surface will do fine. So what you'll do is you'll kind of stick that on the ground layer. We do that, and that's preferred because there's a little layer of air as snow collects on the top of grass blades. And so you end up measuring a little bit of air as opposed to measuring pure snow depth. So that's one of the reasons why a snowboard is preferred. So every 6 hours you take the depth on that board, wipe it clean, and start the process again. You can give us the individual hourly rates. That does have a usefulness for us. But in general, the 6 hour snow depth is what's going to be used for the snowfall amounts. Make sure to take an average of the measurement. So don't just like measure in one place, but measure in like 3 or 4 areas of the snow, just in case a little bit of that snow might kind of be sloping up or down the board. You may want a colorful flag to find your board. I have lost a board in the snow before and not been able to find it until the next spring. So having a flag can help find your snowboard if it gets covered in snow. Good place to measure snow is away from trees and buildings, a nice open site where your snow is going to fall onto your board unobstructed is generally ideal. Measuring ice is a little bit more challenging. There are 2 different ways you can do it. You can either measure it on a flat surface where you kind of just measure the height of how much ice has accumulated on your surface. With a tree, you take a radial measurement where you consider one side of the branch and the other, and subtract off the part that's associated with the actual tree. So in this case, you have 5/6 of an inch and 3/6, but you take off the small part that's left in the branch. You convert it, and you'll get your. This would amount to 1/3 of an inch of ice accretion. Let's see, we have a question here on when we clear off the board, should we place it back on top of existing snowpacks versus putting it back where over time it might be surrounded by higher snow? Yes, so like you can kind of shuffle it around a little bit so that way you don't have snow on the edge kind of caving back in. Oftentimes we'll just rely on snow stakes. At a certain point, if snow is coming down so fast, sometimes there's little that can be done with it. Measuring snowfall is, it's not the most accurate science. We do the best we can with it. One of the important things, we've talked a lot about snow squalls, flash freezes, heavy snowfall rates. When it comes to getting those alerts, best to have multiple different sources of ways to get weather warnings and watches. That can be through NOAA weather radio, alerts through your phone. The wireless emergency alert system is set to organize the most severe threats and alert you when those are in your area. TV broadcasts and media outlets. We have several great local stations that provide and broadcast our watches and warnings and kind of keep you up to date and help communicate and bring that to you, since we're not always on social media or on the TV, since we're sometimes in the thick of it. We might not always have those opportunities. In those instances, TV broadcasters are invaluable to us. We've talked a little about reporting and what to report. Some of the reporting methods that can be done by phone, would be by social media. We have Facebook and Twitter. That can be by amateur radio. We listen to 144.51 megahertz. We also have a storm report page. If you're not really comfortable calling or reporting on social media, you can use our storm report page. And we also have IMPING. We'll go over that, and it's important to share your photos with us as well. So the exciting new addition to IMPING, IMPING is a volunteer thing. You can either use it on your phone or your laptop. That uses your location services on your phone, where you submit a storm report type, and that gets mapped out. This is an experimental program and a public crowdsourced type thing that kind of helps us see what's happening on the ground. Maybe if you don't have other resources available, you can just click quickly that you have snow or rain in your area, and then continue about your day. Of course, we can sometimes get people who put wrong measurements or wrong precipitation types in there. Sometimes we have to make sure to quality check this. But you can download the app on the Apple App Store or via Google Play. That can be one way that you can report these things to us. Snow squall is a new addition to IMPING this year. So if you are in a snow squall, you'd be able to find that under a select report type. The snow squall is under reduced visibility as opposed to rain/snow. But under reduced visibility, that can be one way that you might be able to report snow squalls to us in the future. So just before we go into another segment for questions, just a quick summary and all that we've talked about today. I've unloaded a lot of information on you. I don't expect you to be an expert on this immediately. I always have room to grow in terms of spotting and identifying weather. Any way that we can help, we're always here to answer your questions, and we'll have more training opportunities in the future. But what we've talked about today is what a reliable Skywarn spotter is, why they're important to us. A Skywarn spotter provides ground truth and potentially life-saving information through those reports, whether it be a downed tree, power lines, funnel clouds, heavy rain or wind damage, or whether that be heavy snowfall or ice. Let us know what you're seeing can help our forecasting. Early winter hazards include flash freezes, icy precipitation, where we have systems with strong winds. Sometimes those can kind of combine together to make something that produces lots of power outages. We also are in a favorable time of year now for snow squalls and lake effect snow. So just these outlines some of these new hazards and help kind of prepare your minds as we head from fall into winter. Just a reminder though, as you do your storm spotting, just remember that your safety comes first. You should never put yourself in harm's way to provide us info. Keep yourself safe. As we head into winter, winterize your vehicle and be prepared for cold in case you get trapped in it. We're about at the time of year where Burlington gets its first inch of snowfall. That typically occurs in the middle of November, but it can happen as early as the middle part of October. So we're getting about to that time of year where we have snowfall, so it's time to start thinking about winterizing. All right, we will open the floor here for questions now. I'll go ahead and answer this question from Chuck. Does IMPING data go to a national database or the local BTV office? It goes to a national database, but we have access to it. We can view it here. We have a nice way where we can kind of plot it with what's happening on radar to get a little bit more, get a little bit faster without any kind of latency between when you click the button and when it gets in our system. We have a way we can get a little bit faster, but you can also see, the general public can also see all of the different reports that are going out. It's a nice little resource. We'll advertise it on social media from time to time in anticipation of larger weather events. Just a nice way to quickly and non-committally send a report and then you're done. Oftentimes I'll see people who report as they're a passenger in their cars, or at least I hope they're passengers, because I can see the reports following interstate lines. Those are often instances how I see IMPING used. So I'll go ahead and mute everyone, open up the floor for questions. That can be for flash freezes, for precipitation types, favorable low tracks, about winter weather safety in general, and any other questions about reporting winter weather. So you should be set to go. So if you unmute yourself, let me know your questions. All right, I'm not hearing anything, and we are about up for time, so I think we'll go ahead and wrap things up here. Just a quick reminder, some of the things to report can be anything from a tornado, a water spout, or a funnel cloud, whether or not you're experiencing dangerous or severe thunderstorms that include damaging winds, heavy rain or hail. Lightning damage is also appreciated. Hail of any size is also nice to know. We've mentioned heavy rain, flooding of rivers or streams, heavy snow, whether ongoing significant amounts, whether we need to be issuing warnings in the storm total snowfall, also something important for us. If you're noticing a change in precipitation, whether you're going from snow to freezing rain or from sleet to snow, those are helpful to us, especially if they're unforecasted or if damaging is occurring as a result. So I'd like to thank everyone for your attendance. Thanks for listening. Thanks for your great questions for today. If you are interested in becoming a spotter, please email me at robert.d.haynes@noaa.gov about your interest, and we'll get talking about that. It would be something where I would need your name, address, and your phone number, and I can cross-check that with your attendance here. We'll have a recording up on our YouTube page shortly. That way you can take a listen and ask questions about the course again. We're always looking for feedback on topics that we can discuss, ways that we can improve our webinars. I'd hoped to use a thing called Poll Everywhere to more actively ask questions, but I didn't have quite enough time to incorporate it today for our discussion. But that is something I'm hoping to do in the future. We're looking forward to having talks about avalanches. We're going to talk a little bit about ice accumulations looking down the line. It's been about 4 or 5 years since we've had a webinar on that, so we'll be doing that as well in the future. All kinds of things. We have, not sure if everyone's seen our new, I don't have it advertised here, but we have a new Skywarn page. If you go to weather.gov/btv/Skywarn, we've updated our page and we've been adding resources to that that you can use to both refresh you and interact more with us as Skywarn spotters. That's a page we hope to also update in the future. Lots of updates to the program as well. On the amateur radio aspect of that, we're also looking to try and get we have some of our equipment is a little outdated, so we're also looking to try and update that equipment and get ourselves set so that we can get storm spotter reports more effectively from amateur radio as well. Are there any lingering questions out there? All right, nothing heard again. Thanks again for your attendance and hope you have an excellent day. Bye-bye.